Here we'll introduce what are called central angles and circular arcs. But first, take a look at this angle over here. What's the approximate measure of this angle? Nicely done. Now a central angle is an angle that's between two radii in a circle. So which of these angles down here are central angles? Excellent. So these are the two central angles. Now here's another circle, and let's call it center A, and let's call these 2 points on the circumference B and C. This curved segment over here between points B and C is called an arc. An arc is part of a circle's circumference between 2 points. Arcs are named after their endpoints, so this is arc BC. And to show us an arc, you'll usually see a curve drawn over the letters. And the order of the endpoints does not matter, so you could also call this arc CB. Next, here's a circle with 4 labeled points, W, X, Y, and Z. Which of these are correct names for this blue arc down here? Right, this is arc WY, and you could also call it arc YW. Now the measure of an arc is the measure of its central angle. So here's the central angle for arc WY down here. So what would you say is the approximate measure of arc WY? Nicely done. Next, try finding the measure of this arc AB. This time we haven't drawn the central angle, but see if you can still figure this out. Right, so this arc seems to measure about 90 degrees. Now if you look carefully, there are actually 2 arcs on this circle whose endpoints are A and B. There's this smaller one that measures 90 degrees, and also this larger one that makes up the rest of the circumference. Of the 2 arcs with the same endpoints, the shorter one is always called the minor arc, while the longer one is called the major arc. Minor arcs are named just using their endpoints, so this is arc AB. If you want to talk about a major arc, you'll usually include a 3rd point on the arc, like this point K, so you could call this arc AKB. Next, let's look at a few more arcs. Of the arcs labeled in blue down here, which are major arcs? Precisely, these 2 are major arcs. Let's take a closer look at this one. Suppose I tell you that this major arc measures 210 degrees. Can you figure out the measure of this minor arc over here? If you get stuck, then click over here. Nicely done. So this minor arc measures 150 degrees. And so just as their central angles add up to a complete rotation, or 360 degrees, the major and minor arcs for a given pair of points also always add up to 360 degrees. So now it's time for you to make your own arc. Try moving these 2 points on the circumference around so you have a central angle and an arc that each measure about 60 degrees. Great, so here's a 60-degree arc. And finally, what's the measure of the corresponding major arc that goes with this minor arc of 60 degrees? Here we'll introduce what are called inscribed angles and explore how they're related to central angles. So first, take a look at this circle here. What's the approximate measure of this central angle? If you're not sure, you can click down here to review central angles. Great, so it turns out that this angle measures precisely 120 degrees. Now an inscribed angle is an angle whose vertex is on the circumference. So if we pick a point on the circumference, here's an inscribed angle with the same red arc as this central angle. Again, this is an inscribed angle because its vertex is on the circumference, while a central angle has its vertex in the center of the circle. So next, try approximating the measure of this inscribed angle. Great, so it turns out that this angle measures precisely 60 degrees. Now you might notice that's exactly half of the 120-degree angle over here. Interesting. Let's pick another point on the circumference, like this one over here, and draw another inscribed angle that goes to the endpoints of this red arc. So, what's the approximate measure of this inscribed angle? So this angle also measures precisely 60 degrees. And it turns out that for any point you pick along this part of the circumference, the inscribed angle to this arc is always 60 degrees. In general, for any arc, like this arc here, every inscribed angle is always exactly half of the central angle. Now with this interactive, you can compare your own central and inscribed angles. First, you can make any arc you want by dragging these 2 points around the circumference. Then you can pick the vertex for your inscribed angle by dragging this 3rd point. And the measures of the central and inscribed angles are shown up here. Check for yourself whether the inscribed angle always has half the measure of the central angle. Then, when you're ready, try answering this question. An arc has a central angle of 200 degrees. So what's the measure of an inscribed angle for this arc? Excellent! So next, would you like to work through a proof of why an arc's inscribed angle is always half of its central angle? Or would you prefer to skip ahead to another practice question? Okay, great. To start our proof, here's a circle, and let's draw in an arc. Suppose this arc's central angle measures 2x. It looks like this angle measures about 120 or 130 degrees, but for our proof, this angle could have any measure, so we'll call it 2x. We could pick any point over here for our inscribed angle, so let's pick one, this point over here. So we want to prove that if the central angle measures 2x, then this inscribed angle measures half of that, so it's x. To get started, let's draw in the radius from the circle's center to this point down here. So these 3 blue line segments are all radii of this circle, which means they all have the same length. To show they're the same, let's put a hash mark on all 3 radii. Now notice that we have an isosceles triangle over here. So if this angle is y, then this angle over here must also have measure y, because these 2 angles are opposite from the congruent sides. So then, in terms of y, what's the measure of this triangle's remaining angle? And if you'd like to review how to find angles in isosceles triangles, click down here instead. Nicely done. So this angle is 180 degrees minus 2y. And notice that we have another isosceles triangle over here. Let's suppose this angle here has measure z. That means this angle also has measure z. So in terms of z, what's the measure of this triangle's remaining angle? Right, so this angle measures 180 minus 2z. Now if you look at these 3 angles at the center of the circle, how many degrees must these angles add up to? You should give an exact number, so no x, y, or z in your answer. Right, together these angles add up to 360 degrees. So in other words, 2x plus 180 minus 2y plus 180 minus 2z equals 360 degrees. Let's see if we can simplify this equation a little bit. Notice that we're adding 180 degrees over here and another 180 degrees over here. So we can take all the other terms on the left side, and together these 2 180s make 360 degrees. And this expression is still equal to the 360 degrees from the right side. Next, we can subtract 360 from both sides. So this 360 cancels, and we're left with 0 on the right. Next, let's add 2y and 2z to both sides. So that will cancel out the 2y and the 2z we're subtracting on the left, leaving us with the equation 2x equals 2y plus 2z. Finally, try dividing both sides of this equation by 2 to solve for x in terms of y and z. Exactly. So we started with an equation where these 3 angles in the center add up to 360 degrees, which we simplified to x equals y plus z. So now we're finally ready to look at the arc's inscribed angle down here. This inscribed angle is actually the sum of this angle over here, which we said measures y, and this angle over here, which measures z. That means the total measure of this angle is y plus z, and you just found by adding these angles in the middle that y plus z must be equal to x. So this angle down here has measure x, and that's our proof. Starting with a central angle that measures 2x, we've proven that the inscribed angle down here has exactly half the measure. It's x. Again, here's what we've proven. So try using this fact to solve one last example. In this circle, suppose this inscribed angle measures 50 degrees. Then what's the measure of the central angle with the same arc?